AS Applied Paper 2018, Question 2. A factory buys 10% of its components from supplier A, 30% from supplier B, and the rest from supplier C. It is known that 6% of the components it buys are faulty. Of the components bought from supplier A, 9% are faulty, and of the components bought from supplier B, 3% are faulty. So part A asks us to find the percentage of components bought from supplier C that are faulty. So I'm just going to have a look and note down the information that we know already. So the probability that we have supplier A is going to be 0.3. The probability we have supplier B is going to be, sorry, that's not right. The probability we have supplier A is going to be 0.1. The probability we have supplier B is 0.3. And so therefore the probability we have supplier C is going to be 0.6. So if we know that of supplier A, 9% are faulty, and of supplier B, 3% are faulty, then we can say that supplier A is 0.1 multiplied by the faulty percentage of those, which is 0.9, and supplier B's amount is 0.3 multiplied by the faulty percentage, which is 0.03. And then we've got supplier C's amount, which is going to be the 60%, the 0.6 they provide, times by whatever percentage is faulty, which gives us an overall faulty percentage of 6% of 0.06. So by expanding this, we're going to get that 0.6x is equal to 0.042, and therefore x is equal to 0.07. So the percentage of faulty components is 7%. Part B. A component is selected at random. Explain why the event the component was bought from supplier B is not statistically independent from the event the component is faulty. Now, we know that for things to be independent, we need the fact that PA times PB is going to be the probability of A, N, B. So, what we've got is we know the probability that it's supplier B and it's faulty is 0.03. We know the probability that they're from supplier B is 0.3, and we know the probability that it's faulty is 0.06. Now 0.03 times 0.06 is 0.018, and we can say that 0.018 is not equal to 0.03. Therefore, they are not independent.